You can recognize these two structures right away as being large blood vessels. They are large arteries. And even though they are large arteries, like any vascular channel in the body, they have to ultimately be lined in their lumen by a single layer of endothelial cells, like you see here, 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 here. Notice that the muscular smooth muscle layers underneath look pretty good for a while, but then within the muscular layer you see this inflammatory cell infiltrate disrupting the muscular layer. You can see significant disruption here. You can see significant disruption here. You can see disruption throughout the entire length of this thickness of this artery, as well as some areas of fibrinoid necrosis. But in addition to having a chronic inflammatory cell infiltrate, you don't have to look very long before you see another type of cell. You see the classical multinucleated giant cells. Here's a giant cell here. Here's a giant cell here with multiple nuclei. Here's a nice giant cell here with multiple nuclei peripherally arranged, just like you see with granulomas of TB in other areas. For that reason, this is also called giant cell arteritis. And because these are very common in large arteries, especially the branches of the circle of Willis and the intracranial arteries, and especially in a large artery that is very, very easy to biopsy, which is the superficial temporal artery. This disease has been also called temporal arteritis, meaning that the giant cell inflammation is in the superficial temporal artery. In reality, however, it could be found in many arteries. It's almost always associated with an extremely high erythrocyte sedimentation rate. It also may involve the major arteries of the eyes, so a very clinically, blindness can be associated with this disease as well. Giant cell arteritis, aka temporal arteritis. And here's the nicest giant cell we've seen so far, haven't we? Thank you very much.